How are you, everybody? This is Mr. Nasser. I hope you like this recording. Do you ever notice that the label on the hood of an ambulance is written backwards? This reverse written of the word ambulance is not mistake when viewed through the re rear view mirror of a car. A mirror image correctly show the word ambulance, and the driver can identify whether or not he or she should get out the way. In geometry, we refer the reflection as a mirror image. Unlike direction, a reflection is not a change in size. A reflection is also not change in the shape. For this lesson, we will need to be familiar with common lines of reflection. We know the x-axis and the horizontal line that passes through the origin, the y-axis as a vertical line that passes through the origin, the vertical line equation x equal k, in this case k equal 3. Horizontal line equation y equal k, in this case y equal -2. The line y equal x and the line y equal -x. Reflecting a point line figure about a given line symmetry, we use the lowercase r notation. This notation will specify the line of symmetry for which our reflection will occur. For our first example, we will be reflecting a point that our line of symmetry is the x-axis. This is the line that we are going to be reflecting our point P with coordinates 5, 4 across to find the coordinates of the image P prime. We will count how many units the point P is away from the line of symmetry. In this case, for unit x, we will count the same number of units of the other side of the line of symmetry. So again, for units, we have the location of the point P prime with coordinate 5, -4. When reflecting over the x-axis, we should note that the value of the x-coordinate didn't change, however, the of the y-coordinate was the gated. Going from 4, -4, this reflection rule applies to reflecting any point over the x-axis and where the coordinates xy will become x -y. Meaning that the value of the y-coordinate is negated. Now we can take a look at taking that same point P and this time reflecting in over the y-axis. Our approach here is still the same. We are going to count how far the point is from the line of symmetry. In this case, 5 units. Then we can count the same amount of unit on the other side of the line of reflection and plot the point P prime. The coordinates of this image at -5, +4. Notice that one reflecting over the y-axis, the x coordinate value is negated, and the y coordinate value is unchanged. favor reflection rule, you can say that any point reflected over the y-axis with coordinate xy becomes negative xy, where the x value is negated. For our next example, we are going to reflect a line segment. Our line of symmetry x equals negative 2 is a vertical line equation. Let's start by writing down the coordinate of the endpoint QT. To find the coordinate of the image Q prime, T prime will use the same strategy as the last example by counting how many units. The point is from the line of symmetry. We see that the point Q is 2 units away from the line of symmetry, x equals negative 2, and the point T is 6 units away. We can go ahead and repeat this distance on the other side of the line of symmetry and plot the new points of Q prime and T prime. Now we can construct the image of the reflected line segment. Q prime has coordinates of the negative 4, 7, and T prime has coordinates of negative 8, 3. Now we can go ahead and try to reflect line segments Q over the line of symmetry y equal 3, a horizontal line equation. Note here the point T is directly on the line of symmetry, just like passing your finger up the surface of a mirror, and have up here that another hand is directly touching it, having a point directly on the line of symmetry. We'll have it stay on the line of symmetry, so T prime will have the same coordinates as T at 4, 3. Now the other end point Q still needed to be reflected again. We are just going to how many units Q is from the line of symmetry. We count 4 units and we repeated the distance on the other side again another 4 units and plot the image of Q prime. Finally, we can construct line segment Q prime T prime and identify the coordinate of Q prime at 0, negative 1. And finally, for our last example, we are going to take a shot at reflecting a figure. This case, we will be reflecting a triangle BCD across the line y equals x. We can start by writing down coordinates of the vertex of triangle BCD. We could start by counting on a horizontal path how many units each point is away from the line of symmetry. We see that B is 6 units away, D is 7 units away, and C is 12 units away. Now, since y equal x is a vertical line equation, when we count on the other side of the line of symmetry, we are going to move vertically. So we started horizontally on one side and now are going to count vertically on the other. By matching the same number of units from each corresponding point, we can find the corresponding coordinates of B prime, C prime, and D prime. Finally, we can construct the reflect. Figure the coordinates of B prime at 1, 7. The coordinates of C prime is -6, positive 6, and the coordinates of D prime at -5, 2. Now we can compare the pre-image and the image after the reflection. By turning the graph and seeing just how these two figures are reflected over the line y equal x. Note the coordinate of B at 7, 1 and B prime at 1, 7, C at 6, -6, and C prime at 6, 6, and D at 2, -5, and D prime at -5, 2. This relationship applies to any reflection over the line y equal x when we have a point B with coordinate xy. The x and y coordinate value are switched. The y coordinates value comes first and the x coordinate value comes second. The sign don't change, and now we can take a look reflecting this figure over the line y equals -x. Again, let's start by constructing the line of symmetry and written down the coordinate of the vertex of triangle BCD. Note here. The figure is resting on the top of the line of symmetry that is in two different regions. Now we know that since point C is directly on the line of symmetry, C prime will have a same coordinates of 6, -6. Next point P is located above the line of symmetry. We will start by counting the number of the units horizontally. It's away from the line of symmetry, 8 units. Next step is to repeat the same number of units vertically on the other side of the line of symmetry to find the coordinates of P prime. And finally, since point D is below the line of symmetry, we will start by counting how many units vertically it's away from the line y equal -x, and then repeat the distance moving horizontally above the line of symmetry. Now we have the coordinate of D prime at 5 in -2. By connecting this vertex, we construct the image of P prime, C prime, D prime. To create a very interesting picture, we can rotate the graph to better visualize that this reflecting look like. Now we can compare the point P with coordinates 7, 1, and B prime is in -1, -7. C remains unchanged, and D with coordinates 2, -5, 2. D prime 5, -2. If units for this relationship when reflecting any point over the line y equal -x, the x and y value are switched and negated, so xy becomes y, -x, And now our final words in reflection. Reflection is a mirror image across a specific line of symmetry. For this transformation, you may apply reflection rule for common lines of symmetry. This common lines of symmetry include the x and y axis, the lines x equal k and y equal k, and the lines y equal x and y equal negative x. Thanks. Thank you very much.